Okay, here we go. Let's get started with section 5.3. Since we had a quiz today, we're just going to do this one learning target. Okay, calculate and interpret conditional probabilities. All right, so here we go. We're going to use this table right here, dealing with the subject of pierced ears and gender. Okay, here's the two-way table. This was actually presented back in section 5.2, if you remember it. Let's look at example 13. All right, here's the big picture. If we know that a randomly selected student has pierced ears, what is the probability that the student is male? Let's look at 2. If we know that a randomly selected student is male, what's the probability that the student has pierced ears? Now, they both are dealing with having pierced ears and being male. So you might think the probability is the same, but it's not, because they have different conditions. You have to make sure you are paying attention to the given condition. So the first one, what's the probability that they're male, but it tells us that you already know that the person has pierced ears. Okay, so we interpret it this way. The probability that they are male given they have pierced ears. Look at the table. How many people have pierced ears? That's given, 103. So out of those 103 people with pierced ears, now we can break it down by gender. 84 female, 19 male. Okay, so 19 out of the 103 is called the conditional probability. 2 flips the switch. If we know that they're male, so that's the given condition. So given that they're male, only 90 are male. So you already know they're male. Now we can break it down to yes and no pierced ears. Okay, so what's the probability that they had pierced ears? It was the 19 out of the 90. Okay, so it changes the sample space. That given condition with conditional probability narrows down your sample space. You're not going to use the total of 178. Why? Because all 178 were male. We break it down to the 90. Or vice versa with the first scenario, we use the 103. Okay. All right, here's how they denote conditional probability. Okay, this little line here, you may want to add this to your notes. When you see that, you're going to replace it with the word given. Okay, so this reads the probability of B given event A. Okay. Okay, now this is in your yellow packet, by the way, this conditional probability. It's only written in one direction, A given B, but this one flips it just to make sure you understand both of them. Okay, so probability of A given B, you're going to see a pattern. Whatever the given part is, always goes in the bottom of this formula. Okay, and then up top, it's always just A and B. It doesn't matter, you can flip these around, say B and A, because it will be the same. Okay, so here it is, just B given A now. As you can see, that rule is sticking. Whatever the given condition is what goes down here when figuring this. Okay, so back to this, what was that, scenario 1? Probability of male given pierced ears. We can look at the pierced ears. 103 people have pierced ears, and 19 were male. So we can get that from looking at the table. However, sometimes the formula will be necessary, because you might not have a table in front of you. So just trust me. I'm going to show you how we could figure this out using this formula. Okay, so here's event A given B, right? So what goes on the bottom? Probability of B. So right down here is the probability of pierced ears. Okay, on top, it's the probability of A and B, male and pierced ears. All right, so let's look at those probabilities and grab them from the table. What's the probability that we randomly select somebody from this and they have pierced ears? 103 out of the 178. Okay, what's the probability of selecting somebody that was male and pierced ears? If they had both, it was right here, 19 out of 178. Okay, and as you guys know from your pre-algebra skills, dividing fractions, we multiply by the reciprocal. So we got the numerator times the reciprocal of the denominator. And then these numbers cross-reduce, and what am I left with? 19 over 103. Okay, so that's how we could use the formula. Pause if needed to write that down. I'm moving on. Okay, example 14. This will be the last one, then I'll have you try to check your understanding. Okay, on page 313, you might want to pause and read up on this. Also, while you pause, read the AP exam tip. They have some good advice there. Pause and read now. All right, here's the question. What's the probability that a randomly selected resident who reads USA Today also reads the New York Times? So that's given. Who reads USA Today? That's the given information. So we should write it down like this. Find the probability that they read the New York Times given that they read USA Today. Okay. Now, they did define these events, so you could do B given A. Why? Because B was the New York Times and A was USA Today. So we could shorten it up, but I think putting the context in there is good for notes, good for understanding. Okay. All right. So how are we going to figure this out? You can skip this part. I didn't realize that they defined it up there, so I did it there. So skip it. All right. So using our conditional probability rule, this would be important to write down. B given A. So whatever the given part is what goes down here. So if you put in the context, you'd say probability of reads USA Today goes down here. And this is both New York Times and USA Today. Okay, so we can grab this. Let's go find the probability of reading USA Today. So if they read the USA Today, it's the 35% here that only read USA Today, but these people also read USA Today, right? They read both. So this together is 0.4. So we put that on the bottom. Okay. And we put on top the intersection of the both, right? B and A. So these 5% represents the intersection. Okay. So like I said, you can't always grab it from a table. Sometimes we got to rely on that formula, and here you go. So once we divide that, we get 0.125. What did we just find? So interpreting this, there it is. There's a 12.5% chance that a randomly selected resident from this complex who reads USA Today, or you could say given if you wanted to, also reads the New York Times. Okay. All right. All right, your turn. You guys read the check your understanding. Figure it out. Looks like I totaled a couple things here for you. And they also call it event L, lower than a B. So I put L up there. But I mean, once you read through it, you understand. Answer these questions, and then I'll put the solutions up here when you're done. Pause now and give it a shot. All right, here's number one. This was the easy one. Probability of getting a grade lower than a B. Take all these, 3656 divided by the 10,000. Okay? And here's the interpretation. Okay, now we're going to compare these given conditional probabilities. All right, so here's E given L. I mean, we could use the table, so I'm not sure what you used. You could jump right to this because given that they got lower than a B, so lower than a B was the 3656. What was the probability then that they were from the engineering and physical sciences? And that was 800 of them. So we could just divide those to get that probability. If you use the formula, which is fine, then it might look something like this. You do the probability of L, which is from this first step, and then E and L would be 0.08. You divide them, we're good. Okay, now let's flip this around. I'll flip the given conditions around. So now given that they are an engineering and physical sciences major, so we want this number, 1,600 is all. How many had below an E? And it was 800. So it's 50% chance. 50% of them had below a B. So which of these conditional probabilities tells you that they tend to learn lower grades for the EPS students than the other students? Okay. Well, the problem with using this one given that they had a grade lower than B, is these quantities are different. Okay, so here's what I mean by that. Liberal arts looks like they had, if I add all these up, we're over 6,000 a little bit, right? So these counts should be higher in all the categories because it is a bigger program than the 1,600 there in this program, and so on. So it's not a fair comparison unless all these numbers were the same. So because of that, what you want to do is break it down. What if you are a part of these 1,600? Now we should divide the A's, 368 by this by that, and so on. We can break it down by A's, B's, and below B. And it would be fair to do the same thing here. 2142 divided by the 6,000, and that gives you the likelihood of an A, and so on. All right, so that's why you want to do it the other way. Given they were an EPS student, what's the likelihood of them getting below a B? Okay. So here's my explanation in my own words. This gives the probability of getting a lower grade given that the student is taking an EPS. It allows us to compare the EPS proportions to the overall proportion of lower than a B, or by the other subjects as I was talking about. Okay. All right, so you can pause and read that explanation. All right, so I'll give you a little follow-up problems with the conditional probability. That's it for today. Take care.